So, atmosphere notes. What we're trying to do here is making a diagram that has all the notes that we've done in class on one sheet of paper where they're connected and right next to each other, so it's obvious and it's a lot easier. Here is how I would be taking these notes. You don't have to do everything exactly like I do. Some things aren't going to make sense for you. Some things you might need more words to explain. And if you need to do that, do that. For example, if I put a bird here, and that means that animals live here, but that's not going you're not sure that that's going to be clear later, make sure you write down, like animals live here really small, so you have that later. Anyway, take your blank sheet of paper, atmosphere notes, and along one side, one little column, we're going to go back and find the pressure notes we took earlier this week. We're going to put a diagram in here along the side to help us connect what we're doing here to what we're doing here. Right? So, at the bottom of the atmosphere, here, where we're standing, are the air molecules far apart or close together? They are close together, right? And that's what I'm going to kind of be doing here. At the bottom, molecules are close together. As I work my way up, they start getting further and further apart. Now, here's a box. I'm not going to put any air in there. What's that going to be called? What's it called when there's no air at all, Josh?
A vacuum.
Yeah. Do you see how a little picture can actually take the place of a definition? If these are air molecules and there's none inside the box, well, a vacuum must be where there's no air or anything, right? There's my vacuum. As we move up the page, are my molecules further apart or closer together? So what's their density doing?
Less density.
Less and less and less dense. So we start down here. There's a whole lot of air, a lot of dots. Towards the top, there's barely any. And this is what you should probably have on your page. Now what is causing this to happen? Why are they all piled up at the bottom? Is it worth noting that? Something I don't want to forget? I would definitely note it. Maybe on this one particle, I'll put a down arrow with gravity on it. You see how just that little note there tells you everything we talked about in class. This down arrow, gravity's pulling it down. We've got lots of pressure down here at the bottom. Okay? So this little part of your notes, this is going to be the pressure moving up. On this side of we're going to do the different layers of the atmosphere. Now, in your notes, when you took notes from my notes, from my long form notes, did you start with troposphere on the top or troposphere on the bottom?
Bottom.
On the top, right? But does that make any sense to put it at the top?
No.
It's the lowest layer. It's the closest one to the Earth. Where would it make more sense to be?
Bottom.
It makes more sense to put it in the bottom, and that's what we'll do today. The bottom of my page, if I'm sitting in this class taking notes, I would actually put a little rounded spot and call that the Earth. And I would start right there. Here's the Earth. Okay? Now as we move up, we'll have these different layers. I wouldn't fill it all in, but make sure you know that the thermosphere, the very top layer, is going to take up, it's got a lot of notes, so don't try to fill your space up right away. Okay? Now, the atmosphere. There's different layers to it. The troposphere is the first one. So troposphere. Here's a great example of how a diagram will help connect things to us. The first thing you would be writing down if you were just copying off the board is that the troposphere contains 75% of all air. Now you could write that down, but is there a way you could get that in drawing form here? Can you think of it? The cloud will be next. How would you do it, Ian?
You can put like a lot of air molecules.
We already have, haven't we? I would just put a bracket here and 75%. 75% of all the dots on this little part of your board are right here in the troposphere. Do you need any more words than that? I wouldn't need any more words. Can you have more words?
Yes.
Feel free to write this all out if you want. The next bit of notes. It contains all weather. All weather is in the troposphere. Now, do we have to write that or can we just draw it real easy? Draw a cloud. Yes, pretty little puffy cloud. Uh-oh. Lightning bolt. Raindrops. Okay? You can label all weather there, but putting a cloud is one way to just make it a little more memorable. A little less forgettable, you could say. Wish my smartboard was working. Okay? What did I mean by this little shorthand here? I put an up height, down temperature. What does that mean? What does it mean, Mitchell?
When you go up, the temperature goes down.
Yep. And, you know, if you can't think of a good way to draw that, you could just write it. But up, okay? If it were me actually taking these notes, I might just put a big down arrow for temperature. But as you go up in height, you go down in temperature. Those are the main things I want you to know about the troposphere. Okay? It's not a lot. Okay? Now let's see one of the benefits of doing a diagram like this. Does the troposphere have a little bit of pressure or a lot of pressure? How can you tell that? How can you tell that, Jordan? It's the bottom layer. There's lots of air molecules. Where's the air the most dense? Did we ever say that? No, but it's implied by drawing a picture and connecting this stuff. And this is how I would connect the notes in my mind and start saying, oh, hey, okay, we learned about how air is more dense. That just makes sense. Troposphere. Now, at the top of the troposphere is the jet stream. Almost forgot about it. Should we just write top of the troposphere is the jet stream? What should we do?
Make like a jet flying.
Why do we draw the jet stream? Where should we draw it? At the top of the troposphere. So above the cloud. There's the jet stream. Okay? Now the weather we have outside is directly related to that jet stream, and we'll learn more about that when we get to weather. A lot more about the jet stream. But all of you need to know for now is that it's the very top of the troposphere. So, that's it for troposphere. On to stratosphere. Key point here is that it contains the ozone layer, which absorbs ultraviolet light. Is there a way we could draw that? A way we could convey that, not with words? Yes?
Make a thin layer of ozone.
Okay. What about the UV light thing?
And then put little arrows that have the little arrows going down.
So UV coming down, hitting the ozone, does it stop there then?
It doesn't stop.
Well, yeah, yes.
Yeah, it does. So here comes our UV light. It's coming down. Stops right there. Now in this case, unlike the troposphere, as we increase in height, what happens to the temperature? It goes up. So in this case, maybe over here by ozone layer, I want to put it up temp. Do you think the absorbing UV light and the increased temperature are connected? They are. Yeah. If you are filtering out all this energetic light, you are going to increase in temperature too. And that's why the stratosphere gets warmer. Mesosphere. What's meso mean again? Meso forte, medium or middle. So the middle layer, this one's going to be a little easier. Shooting stars burn up here, or meteors burn up here, which we normally call shooting stars. Every movie you've ever seen where they're re-entering the Earth's atmosphere and they're burning up, that's happening way up here in the mesosphere. Do we have to write that down, or think of some way we could convey that?
Draw a shooting star.
Draw a shooting star. Hey, yes. Okay. Now is my drawing to scale?
No.
My goodness, no. But if we're only going to fit on one sheet of paper, you just might have to keep it in mind. The mesosphere is actually gigantic. But today it's not. Shooting star. Here's my shooting star. It's a big guy. It's bright. It's actually just a little pebble from space, but they burn bright. Now, as you increase in temperature, what happens to the temperature? Excuse me, as you increase in height, what happens to the temperature? It goes down. That was in the reading. Maybe the only way to convey that is just a down arrow that says temp. From the homework, where is the coldest part of our atmosphere? You know? Yeah, at the very bottom of the mesosphere. Or is it the top of the mesosphere? The top of the mesosphere. It just gets colder and colder and colder until it's really cold. And it warms up from there. Mesosphere, notes are short. Thermosphere. Now, before you write thermosphere down, there are two sublayers, two parts of the thermosphere we're going to talk about. And so instead of writing thermosphere and then confusing ourselves, one trick you start picking up with doing notes graphically like this is how to organize it so it's not confusing. And here's how I would do that. I would write thermosphere like this. I would box it, and now we can talk about the two different layers inside without confusing ourselves. Okay? Now, under the notes here I have the thermosphere has very thin air. Do we have that on a drawing? Do we need to draw that?
You just do that with the
Do we already know that here?
yeah, you're shooting sand.
It's the exact same thing. I already have that there, don't I? I'm not even going to write that. Very thin air. Push my spark forward. As you increase in height, you increase in temperature. So their molecules get hotter and hotter and hotter and hotter. Now, if you wanted to draw that, you could draw really hot molecules up here. But you might. Yep, so as you increase temperature, or as you increase height, you increase temperature in the thermosphere. The first sublayer of the thermosphere is called the ionosphere. Do you guys know what ions are?
Yeah. Sounds
Not ions. Ions. Ions are charged particles. Charged particles. Now, maybe this would make more sense as a high school chemistry kid, but the ionosphere Yep, this is inside the thermosphere. That's why I put this one sideways and this one normal ways. Yep. The ionosphere has charged particles. Little pluses and minuses, to me, represent charged particles. If you don't know that pluses and minuses mean charged particles, what could you put by these pluses and minuses?
Charge.
In parentheses, write charged particles. And then you'll know, oh, there's charged particles there. This is where the northern lights happen.
Beautiful.
I've got some really great stories about northern lights, but we'll save them until we're in space. Coming up. Last one. Absorbs very harmful radiation from the sun, like the really bad stuff coming out of the sun. The sun is sending out gamma rays and X-rays and stuff that astronauts actually are exposed to that they shouldn't be. No one really realizes it. This ionosphere takes care of it for us. How can we get it on here? How do we get the UV filter in here? UV stops. If we put X-ray, arrow, stopped? What does that mean? It means X-rays are coming and they are stopped in this layer. Or gamma rays. Gamma rays, same thing that made the Hulk. Come through and they are stopped in the ionosphere. Right? Because we don't want to run out of time. The last one is the exosphere. This one's super short. The exosphere is normally thought of as space. But because there are just a few molecules here, like zimming around, like a couple per square meter, a couple of molecules per square meter, then we consider it as a part of the atmosphere. So exosphere, and all you need to put here is a nice little satellite.
I think I'm drawing a spaceship.
Draw a spaceship. Draw a little astronaut on a cord. Do whatever you need to do. That's our notes.